What we're going to look at in this video is we're going to look at how we calculate the distance between any 2 points given within our plotted system. So what we're going to look at is taking 2 points, which we'll call A and B, and we're going to look at how we find the distance between the two of them when we're given the coordinate of each of the points. So imagine, in general, I have my 2 points. I'm going to have the point A, which I'm going to give as x1, y1, and point B as x2, y2. So just two generic points anywhere within my system. So imagine I plot them. So there's my x and my y axis plotted. There's where my point A is. I'd have it joined up to a point B is. And I want to know the distance between the two of them. So I would want to know, let's call it D, the distance between the point A at x1, y1 and the distance to point B given by x2 and y2. Now, what we have to do is figure out how we calculate that. Now, if we had rulers and we were able to do things accurately, it'd be great. We could measure it there. But imagine we're not. So when we get to this stage and higher, we're not looking to draw it purely exactly, using the squares and then measuring things and working it that way. However, what we're able to do is imagine if we draw dashed lines in this sort of system here. What we could do when we do that is create what looks like a little right-angled triangle. What we're then able to do is figure out the sides that are missing here using our points A and B and work that through as part of a right-angled triangle. Now, if this is a right-angled triangle, this side going up and down here, which is a vertical one here, is when we start at this height here, which is equivalent of our y1, and it goes all the way up to the height there, y2. So in terms of getting the length of that line, we figure out where we ended up, so our y2, and we take away where we started, our y1, and that tells us how long this line is. Similarly, we could do the same going across, except it's the x's we looked at. And in this case, for this one going along, we end up with x2 minus x1 for the length of that side there. So I've got the sides here that I'm allowed to now able to use Pythagoras' theorem to calculate my d in here. Now think about Pythagoras. A squared equals b squared plus c squared. A would be this, B would be here, and C would be here, but I want the D on its own, so I'd have to simplify that by taking the square root. So to get a distance based on that, I would know it would be x2 minus x1 squared plus y2 minus y1 squared. However, to get rid of the squared for Pythagoras and just get the distance, so the D, I would take the square root of the right. So what this one here does is this tells me the distance between any 2 points where I have A located at x1, y1, so 1 point, and B located at another point, x2, y2. This here allows me to calculate the distance there between them. So, let's have a look at how we would work this. Imagine I've got 2 points, so let's take an example here. Imagine I've got 2 points, so I'm going to say that I've got a point A, which is located at -1, -4, and I'm going to tell you I've got the point B, which is located at 7, 8. And I want to know the distance between A and B. Well, in order to do this, we'd think of the formula that we're after. So we know the formula that we're after using is x2 minus x1 squared plus y2 minus y1 squared. So to do this, what we have to do is figure out where the x2, y2, x1, y1 come into play, substitute them in, and then calculate it through. So up here, we label our 2 points. So I'm going to label A as being x1, y1, and B as being x2, y2. And I'm going to substitute them in. So in doing this, my x2 minus x1 becomes quite simply 7 take away -1 squared. My y2 minus y1 becomes 8 take away -4 squared, and then I've got the square root overall. Then it's just a case of doing each of the numerical parts itself. So 7 minus -1 becomes 8, so it's 8 squared. 8 minus -4 becomes 12 squared. 8 squared, 8 8s is 64, plus 12 squared, 144. So that means we end up getting the square root of 208. And we could just leave it like that. That gives us our exact value for what we're after. So there you go. Our distance between those 2 points, D, is equal to the square root of 208. We don't know the exact units, whether it's centimetres, etc. So we could just say square root of 208 units. Now, this works the same regardless of the kinds of numbers that we have, whether we've got just normal simple whole numbers or we start to bring in fractions or even square root numbers. So imagine I've got 2 points. I'm going to tell you that A is a half, comma, negative 15 over 4. And I'm going to tell you that B is given by negative 1, negative 1. And I want to know the distance between A and B in this case. Again, regardless of what numbers we've got here, we stick to the same formula. So it's still going to be square root of x2 minus x1 squared plus y2 minus y1 squared. The only difference it's going to become is the fact that we've got slightly more interesting numbers. Yeah, let's call it that. So it's going to be slightly more interesting results we get through here. Same steps. We start by labeling the 2 points. x1, y1 and x2, y2, and then we plug it all together. So we start to substitute them in. x2 minus x1 gives me negative 1, take away a half, and that's squared. So then plus y2 minus y1, so negative 1, take away negative 15 over 4, and that's squared as well. It's then just a case of doing each step on its own. So negative 1 take away a half gives me negative 3 over 2, and that's squared. Plus negative 1 minus 15 over 4, so negative 1 plus 15 over 4 gives you 11 over 4 squared. Square both of them. What that means is I then get 9 over 4 plus 11 over 4 squared, 121 over 16. I want to combine them both into one fraction. 9 over 4 can be written as the same as 36 over 4. So that means I've got the square root of 36 plus 121, 157 over 16. I can simplify that, take the square root of both top and bottom, square root of 157 over square root of 16, which is 4. And again, we don't know what units it is, so we just call it root 157 over 4 units. That's how long the whole thing is. When we're working with the distance between 2 points, this is the formula we have to follow. We have to figure out and use that D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We get the x2, x1, y2, y1 from our 2 points. Key thing we have to make sure we do is label our x's and y's together. So x1, y1, x2, y2. We don't mix them up. So you don't label it as x1, y2, x2, y1. We have to keep them together. If we don't, we end up with something that ends up going a bit wrong.